So I want to just comment that the two axioms that I've introduced so far are examples of what we call incidence axioms. They are axioms that say how the different objects relate to each other. So, for instance, through any 2 points exists a line. This is stating some kind of fundamental relationship between points and lines. And likewise, there exist three non-collinear points. These are among the incidence axioms, and in the future videos, we will see more incidence axioms. But the main thing that I want to talk about in this video is something else, which is that we can construe these axioms and the objects that we're working with even more abstractly than I have been doing so far. And I know that what I've done so far is actually so abstract that somebody who had no experience with sort of proof-based geometry, right, that this would be a very hard, if not completely unintelligible, sequence of videos. So already the presentation has been abstract, but here I'm going to present it in an even more abstract way, and so this video and the next, which will continue on the theme, is maybe not for everybody, but if you're interested, here's just a little description, and it's mostly just for fun and curiosity, that we could pick objects, right? We could imagine that the axioms are satisfied by certain objects that are very different from what we imagine when we think of these axioms and use the words that we use. So, for instance, the axiom only requires that three things exist, right? 3 points. So I'll take my whole space, my whole universe, to be just these 3 points, A, B, C. And that's all that there is in the universe, and it will satisfy the axioms. As long as I then also define my lines and whatnot in a way that I make sure I satisfy the axioms. So here I do not have a geometry. Why? Well, I do have that points A and B determine a line, and that it's different from the line AC. So I definitely have that I have that A and B determine a line, A and C determine a line, and I have that those points are not collinear, right? The line through A and B does not contain C, so A, B, and C are not collinear points. So this almost satisfies all of the axioms, except that not every 2 points determines a line. Namely, there is no line determined by B and C. We need that in order to satisfy axiom 2. So if I then included this as another line, in fact, I could define it as some line P, or whatever. I could say that this is a new line, or I could say, in fact, that it's actually I was going to say that I could call it line M, but that's not true because M is precisely equal to the set AC. So no, I would have to call this a new line, and if I did that, then I would be satisfying both of the first 2 axioms. Every 2 points determines a unique line, and there are 3 non-collinear points. And now I really have a geometry, something that satisfies the first 2 axioms. And I'll continue on this theme, but this video and the next may be a little abstract for some people, so skip them if you're not interested in, these abstract geometries and relationships to graph theory.